Assalamualaikum everyone. So today we are going to solve AS paper advanced practical skills, okay, and it's variant 32 from 2007. So in this paper the total time allowed is 2 hours and you will have two questions. For each question examiner will give you 1 hour to solve to attempt that paper, okay. So first let's start with the instructions what we have to do. From there you have to answer all the questions and you will be allowed to work with the apparatus for a maximum of 1 hour for each question. So two questions, 1 hour for each question, okay. You're expected to record all your observation as soon as these observations are made and plan the presentation of the record so that it is not necessary to make a fair copy of them, okay. So when you are doing the practical you have to take the readings and you have to note it down side by side, the working of the answers to be handed in, okay. Then okay, additionally answer paper and the graph paper should be submitted only if it become necessary to do so, okay. And you are reminded of the need for the good English and clear presentation in your answer. This is very important. When mostly students are making the table, they don't make it in the proper format, okay. So you have to follow the format for the practical. The data as much it is clear, it is easy to understand, and your calculations will be accurate, okay, when you follow these instructions. Okay, so let's move forward. We are going to attempt the question 2 of this paper, okay. Question 1 is from the electricity and we are going to discuss its question 2. So let's discuss this one. Okay, first thing, the examiner in the lab setting, you may not need to use all of the material provided. They will give you some of the extra material, okay. So you should know which material you have to use. So for that thing, first you need to know the name of all the apparatuses. So let's discuss how we can do that thing. What they are asking us in the experiment, in this experiment you will investigate how the rebound height h of the table tennis ball is related to the height d from which it is dropped, okay. So there are two heights. One is the height d. This is the height from where you're dropping the ball, okay, and it's going to hit the ground and it will rebound and it will again come to some height, but it will be less than h will be less than d, okay, this height. So this is the equation that they have given. If A resistance ignored, the theory predict that E is equals to under root h over d, where E is a constant. A resistance may be ignored when d is less than 40 centimeter. So if you notice, they are telling us that when A resistance ignore, this equation is valid that you have to use, and A resistance can be ignored when the height is d is less than 40. So this experiment will be, you have to drop the ball from the height less than the 40, okay. If you take value equal to 40 or greater than 40, your experiment will be wrong, okay. So what we have to do, they're telling us mount a half meter rule vertically using a stand, boss and clamp. So first you need to know what the stand is, boss is and clamp is. So this is the stand, okay, and this we call boss and this we call clamp, okay. So first you need to know their names, then you have to arrange the apparatus in a way they have shown you in the diagram. So you have to make it like this, okay. So you just have to look at the diagram and you have to arrange it in that way. Make sure your scale is perfectly vertical, it's straight, okay. So how to set the apparatus, let's look at that thing first, then we will move forward with the experiment. Okay, so what I'm doing, I'm trying to adjust the scale with the help of clamp, boss and stand, so we can take the reading of the height and the h and d, okay. So you have to adjust your boss to the height. It does not matter in this experiment on which height you are adjusting the boss, and you can adjust the clamp so it can hold the scale. Okay, and you have to make sure that the scale is perfectly vertical and it should be placed on the table. Okay, so I'm trying to adjust it, and make sure there is enough space because you have to bounce the ball and you have to take the reading of it. So the scale should be in front of you and the ball where it is bouncing. Okay, so what is the mistake here? My zeroth of the scale is not on the ground, on the table, so it will be difficult for me to take the reading. This is the easier way if zeroth is on the table. So I'm going to choose any height. I have chosen 38, from where I'm going to drop this ball, and to avoid parallax error your eye should be in level with the scale. And again, to avoid parallax error, choose some height and take the reading of H and D. Okay, so this is how we are going to take. Okay, so let's solve the paper now. We have the question, but I have taken the height. I have taken D 35. Okay, so I'm going to drop the ball from 35. Okay, you have to take the reading from the bottom of the ball as shown there. Okay, so when it will fall, what I'm going to take the reading of H, the rebouncing of ball height. Okay, so I have repeated this value for 3 times. I am getting 29, 30 and 28. So you have to take the average of 3 values. So value 1, 2 and 3 divided by number of values. So there are 3 values, so it will give you 29. So D is 35 and H is 29. Okay, so you're done with the question. Explain how you use the apparatus to ensure that the rebound height H was measured as accurately as possible. Okay, so what we can use a set square to indicate height, or we can repeat the experiment, okay, as we have done. Okay, so you can take the multiple readings. Examiner will not give you the marks if you're just going to write down use a set square. Okay, you have to write down properly that you are using the set square for measuring height. Okay, in the next part you have to estimate the percentage uncertainty. First thing, estimate. So different student can get the different answers, so the answer should be within the range. Okay, how we can find it? There are 2 ways to write down the uncertainty. One is calculated from the least count of the apparatus, that is half of the least count. Okay, but in this experiment the uncertainty will be more than that because of the different reasons. One, the human reaction time. The ball is moving and you are measuring the height of that thing. The parallax error that can cause, okay, also that will increase the uncertainty in it. So the preferred way, what examiner wants from you to find the uncertainty from the range. So what is the method? The absolute uncertainty delta H will be equals to half of the range. What is the range? Range is the maximum value and the minimum value that you have measured above. So if you see there, I have 3 different values. Maximum is 30 and minimum is 28. So my range is 30 minus 28, and you have to divide by 2. I will get 1. Okay, so for absolute uncertainty, for percentage uncertainty, what you have to do, you have to divide absolute uncertainty with the measured value and multiply with 100. So you will get 1 over 29 multiplied by 100. This is 3.44. Okay, so any value within the range of 2 to 10 for this question is acceptable by the examiner. Okay, then you have to find E. How we are finding E? That formula is already given in the question. Okay, so you just have to put the values that you have calculated. H is 29 and D is 35. You get 0.91. Okay, moving forward, they are saying repeat A2 and B5 using a different values of D. So you have to choose any different value, but make sure the value should be less than 40 and different from the previous one. So I have chosen the 30 height, and what I have, D is 30 and the readings I have taken is 24, 25 and 24. Okay, these are the readings I got. So when you take the average, it will give you 24 approximately. And again you have to find the E. So again use the same formula, put the values, we will get 0.89. So these are the values we have got. Okay. In the C part, do the result of your experiment indicate that E is constant within the limit of experimental accuracy? Okay, what is the limit of experimental accuracy? If the values are within the range of 20% or 20% or within this range, so they can be considered as equal. Okay, so if you see, first thing we have to write yes. Why? Because one value is 0.91, the other one is 0.89. If you see the difference of both of them, it is 0.02. That is very small value. So if you, what you have to do, if you see the range, just imagine the 20% of 0.91. So its range will be 0.91 plus the 20% of this value minus the 20%. This will be the range of this value. For this thing, 20% of 0.89, 20% of plus, and 0.89 minus, this will be the range of this thing. So these both ranges are overlapping with each other, so they can be considered as equal. So you simply have to write down 0.91 and 0.89 differ by only 0.02. that lies in range of limit of experimental accuracy. Moving forward to the next part, state 4 sources of error or limitation of procedure in this experiment. So there are multiple answers. I have written 6 of them. You can choose any 4 from there. Okay, so you can use the two set squares set. You can use two set of readings are not enough to draw the valid conclusion. Okay, we have taken the 3 reading. We have taken the 2 readings of E. Those are not enough. If you have to compare E, it is equal or not, you have to take multiple readings. As we do in some experiment, we take 6 readings, we plot the graph, and then we can say something about the value. Okay, then it's hard to judge rebound height of the ball because of the motion. The ball is moving continuously, so human reaction time also involved, so it's hard to judge the height accurately. Then the parallax error is there. Difficult to release the ball freely. When you are going to release the ball freely, what is required? You don't have to apply any force, but when you are dropping it with the hand, there is a high chance that you will intentionally or unintentionally apply some force on it. Ruler might not be vertical or perpendicular, and bouncing of ball from the table can be inconsistent because of the surface or because of the different environmental factors, like it can be the air from the fan, or it can be some something that is placed on the table that can cause the irregular bounce. Okay, then you have to suggest the improvements. So you have to suggest four of the improvement. I have written 6 there. You can choose any 4 of them. So we can increase the reading. We can take the multiple readings of E and we can plot the graph to compare. Okay, so we can use the video and we can play back it slowly to accurately measure the height. We can ensure measurement taken at eye level to avoid the parallax error, right? Use mechanical method of releasing ball, so no force will be applied on it. It should be falling freely. Make sure scale is placed vertically. Okay, how you can make sure it? You can see the scale from the distance, from the sides, to make sure it is placed vertically, and you can judge it easily. And you have to use the flat table surface. So this was the last part of the question. So see you in the